Okay, so today is day 3 of me trying to become a cracked dev, and I guess uh I mean last time I was working on C++ and I was learning the basics, but today I'll be continuing that actually. However, there's some changes I made in my I guess developer experience, and I guess I'll just show it off real quick. So now I actually don't use the terminal that is built in Mac. I'm gonna now use iTerm. The reason as to why that is because now I use NeoVim. So yeah. All right. So all right, cool. Sure. Let's open this. I should have the thing for C++, I think. Now I need to remember how to actually. Okay, hold on. Okay, cool. So, how to compile with Clang. How do I actually compile with Clang? Okay, let's see. Clang. I guess ++ hello world.cpp -o hello world. Oh, oops. -o hello world. Okay. Enter 3 numbers. Yeah. Cool. Anyway, so I guess now I remember how to compile. Anyway, so basically what I'm doing is I'm actually using NeoVim with a lot of plugins, and yeah, that's pretty much it. So I'm gonna try to develop with this now. Yeah. So let's try to recall what I learned last time. So this is the preprocessor directive. It includes the libraries that we're going to use. This is my main function, which returns an integer, returns 0 if everything goes well, something else otherwise. And here we are putting to the standard character output, enter 3 numbers with a space. We're doing direct initialization of these 3 variables. And then I'm doing standard character in. I'm putting in this one, or actually rather I'm taking as input this one, but then when a white space is encountered, it stops, so then I have to call it again, white space, etc., etc. And then it does work. The buffer basically runs out, and then I get these. Okay, cool. So let's continue. So let's continue by reading uninitialized variables. Oh my gosh, I have so many notifications on my email. Okay, so unlike some programming languages, C or C++ does not automatically initialize most variables due to a given value, such as 0. So when a variable that is not initialized is given a memory address to use to store data, the default value of that variable is whatever garbage value happens to already be in that memory address. Okay, so a variable that has now not been given a known value through initialization or assignment is called an uninitialized variable. Many readers expect the terms initialized and uninitialized to be strict opposites, but they aren't quite. In common language, initialized means the object was provided with an initial value at the point of definition. Uninitialized means the object has not been given a known value yet through any means, including assignment. Okay. So therefore, an object that is not initialized but is then assigned a value is no longer uninitialized because it has been given a known value. Okay, so to recap, the object is given a known value at the point of definition, then it's initialized. Assignment is the object is given a known value beyond the point of definition. Okay, got it. So this is uninitialized. We know that when no initializer is provided, the variable is default initialized. In most cases, such as this one, default and actually initialized. Okay. Let me make sure my stream is properly working as well. Let me just go on YouTube and check that this works. Is it working? Okay. Let me make sure my stream is properly working as well. It seems that it is. Okay. All right. Right. When no initializer is provided, the variable is default initialized, right? We noted that when no initializer is provided, the variable is default initialized. In most cases, such as this one, default initialization performs no actual initialization. Thus, we'd say that x is uninitialized. So we're focused on the outcome. The object has not been given a known value, not the process. As an aside, this lack of initialization is a performance issue, optimization inherited from C, back when computers were slow, right? Okay. So imagine a case where you were going to read in 100,000 values from a file. In such case, you might create 100,000 variables, then fill them with data from the file. Now, if C++ initialized all of those variables with default values upon creation, this would result in 100,000 initializations, which would be slow and for little benefit because you're overriding those values anyway. For now, you should always initialize your variables because the cost of doing so is minuscule compared to the benefit. Once you are more comfortable with the language, there may be certain cases where you omit the initialization for optimization purposes, but this should be always done selectively and intentionally. So using the values of uninitialized variables, can lead to unexpected results. Okay, consider the following short program. So we have int x, so we're defining this integer variable. It's uninitialized because we haven't given it a value yet. Print its value to the screen. Who knows what we'll get? Let's try it out. So let's see. I'm just gonna take like visual mode down here, and we're gonna go up and we're gonna delete everything. Actually, not everything. Go down here and enter the line, delete, go up here, and we're gonna start writing some stuff here. But first of all, this needs to be formatted correctly. Okay, let me just format everything correctly. Okay, there's a return 0. Now let's see. So int x, a standard, whoops. That's strange. Int x, standard, okay. Cout, character out. We're putting in the character x and then the escape character, which is this. Okay, cool. Now write it, and now what's gonna happen? Let's see. So if I go into my terminal and I run my command, whoops, go into my terminal, run the command, compile it, do this, boom. That is strange. Okay, so I think what this is that it's the garbage kind of value or whatever was there. Actually, you know, why don't we try it one more time as well? let me just like go back to this program. And what if I just what if I did it again but for y or something? Yeah, I'm gonna yank it, and oops, oops, that's not what I meant to do. Anyway, yeah, that's what I meant to do. Now I'm gonna go to my terminal. Does that work like this? And I'm gonna go up this, do this. Yeah, that's strange. Okay, anyway. So, right. So in this case, the computer will assign some unused memory to X. And it will then send the value residing in that memory location to standard cout, which will print the value interpreted as an integer, right? But what value will it print? The answer is who knows, and the answer may or may not change every time you run the program. So when the author ran this program in Visual Studio, that printed this one time, this the next, feel free to compile it. Yeah, okay. Some compilers, such as Visual Studio, will initialize the contents of memory to some preset value when you're using a debug build configuration. Okay, that's not what I'm using anyway. Most modern compilers will attempt to detect if a variable is being used without being given a value. And if they are able to detect this, they will generally issue a compile time warning or error. For example, compiling the above program on Visual Studio will provide okay. Used, okay. Now, if your compiler won't let you compile and run the above program because it treats the issue as an error, here is a possible solution to get around this issue. Void do nothing int. Alright, so this is for pointers, and that's what I understand. Don't worry about what it means for now, but okay. So it's a pointer to an integer, but whatever. We're just using it to trick the compiler into thinking variable x is being used. Okay. Let's see. So it takes in the pointer. Okay. We're just tricking the compiler to think that variable x is being used. Define an integer variable named x. Do nothing. Make the compiler think we're assigning a value to this variable. Okay. Who knows what we'll get because x is initialized. Okay, that's interesting. Actually, I want to see what happens. This is actually the first time that we're writing a function finally. So let's do it. So void do nothing. It takes a pointer int and it just does nothing. Good. Now I'm gonna do that. Do nothing x, and I'm gonna delete this. Right. Now go like this. Oh. Let's see. Clang ++. Yeah. Okay. Let that happen. Hello world. Okay. Now using uninitialized. Oh wait, hold on. Did this compile? This is kind of funny. Hold on. Wait. Okay, first of all, I should probably move this over here. And I'm just gonna move this over here, this over there, this over here, this over there. Should be a little easier. Okay, good. So what was I doing again? Okay, yeah. Let me just check if it's really like properly compiling because this is strange. So let me compile it one more time. Hello world. Okay. Using uninitialized variables is one of the most common mistakes that novice programmers make. And unfortunately, it can also be one of the most challenging to debug because the program may run fine anyway if the uninitialized variable happens to get assigned to a spot of the memory that had a reasonable value in it, like 0, for instance. Yeah, that makes sense. So this is the primary reason for always initialize your variables. Yeah, okay. Undefined behavior. Now, using the value from an uninitialized variable is our first example of undefined behavior. So I hear that all the time, and now I guess we're getting a good example of it. Undefined behavior is the result of executing code whose behavior is not well defined, by the C++ language. Yeah, because it can get so many things. Like this program, it can print all sorts of things, depending on which machine you're running it on, depending on when you're running it, etc. So yeah, it's undefined because it doesn't always give you the same thing. Okay. Now in this case, the C++ language doesn't have any rules determining what happens if you use the value of a variable that has not been given a known value. Consequently, if you actually do this, undefined behavior will result. Okay. Now, code implementing undefined behavior may exhibit any of the following symptoms. Your program produces different results every time it is run. It consistently produces the same incorrect result. Your program behaves inconsistently, sometimes the correct, sometimes not result. Your program seems like it's working but produces incorrect results later in the program. Your program crashes either immediately or later. Your program works on some compilers but not others, and your program works until you change some other seemingly unrelated code. Or your code may actually produce the correct behavior anyway. Okay. C++ contains many cases that can result in undefined behavior if you're not careful. Okay. Yeah. So uninitialized variables, that's the first really big situation I think where we have that we're being introduced to in terms of undefined behavior. Good to know. Okay. Implementation defined behavior and unspecified behavior. Okay. So a specific compiler and the associated standard library it comes with are called an implementation, as these are what actually implements the C++ language. Fair enough. So in some cases, the C++ language standard allows the implementation to determine how some aspect of the language will behave. So that the compiler can choose a behavior that is efficient for a given platform. Behavior that is defined by the implementation, it's called implementation defined behavior. Wait, let me read that again. So a specific compiler and the associated standard library it comes with are called an implementation, as these are what actually implement the C++ language. So in some cases, the C++ language standard allows the implementation to determine how some aspect of the language will behave, so that the compiler can choose a behavior that is efficient for a given platform. Behavior that is defined by the implementation is called implementation defined behavior. Implementation defined behavior must be documented and consistent for a given implementation. Okay. Interesting. Let's look at a simple example of implementation defined behavior. Oh, my computer's hot. Oh, my computer's really hot. Oh shoot, that's not good. Why is my computer so hot? Anyway, let me see. Right. This I understand because the size of integer, on some implementations, it might be different, depending on your architecture or like your system. So depends how many bytes of memory an int value takes, right? So on most platforms it'll produce 4, but on others it may produce 2. Right. So let's see. Oops. That's not what I meant to do. Let's see. Size of, let's say, int. I want to also see, let's say, size of, let's say, I don't know, let's say double or something, or let's say, wait, let's say bool. Yeah, bool. So I want to save this program. I'm going to go to my terminal. Oops. Go to my terminal. This is so annoying, but I'm glad. Now VS, what's it called? Vim, it tells me about it, which is really nice. Man, that's actually crazy. I love Vim. Okay. Compiled. 4 and 1. Okay, cool. You know what? I should probably check something. Okay, hold on. Wait a second. How to create a script to compile in like Vim or something. Let's use ChatGPT. I want to create a bash script so that I can take a file with the file name, for instance. Wait, hold on. A file such as file and immediately do, let's see, I don't know, do line plus plus mv and I'm not sure what this does, this set E, but whoops. So let's see, dash E. Okay, so first I'm going to check if a file name was given. So let's do that. If, I guess, let's say, whoops. Shoot, what the heck am I doing? If $1, then echo usage $0 cpp underscore file. Okay, exit 1. Fee. Oh, that's not what I meant to do. Exit 1. Now fee. Now get the base name, strip the .cpp extension. Okay, so my source is going to be equal to whatever is there, and the base is going to be equal to whatever I have here, but remove cpp. I'm assuming that's what it means. Okay. Now compile with Clang. Compile with Clang++. Okay. So plus it's equal to C plus 17, right? Wall extra, not sure what this does. Is that 0 or is that O? I'm gonna say O2. That looks like a, yeah. Source dash O $ base. Okay, that makes sense. And now we're gonna run the executable, which is very simple. We're just gonna echo, we're just gonna echo running / $base, and then we're gonna actually call it base like this. Oops. So I'm gonna write it. Oh, right. Okay. So now, what do I do? Save it. How do I even save it then? Can I save it? Dude, I just want to save it. What? How do I save a script like this? Broski. Can I quit? Yo, dog. Okay, like I don't understand. How do I, let's see. I can't even do on Vim because it's saying permission denied. Wait. Oh, okay. Sure. Sudo %. Bro, you gotta be kidding me. Oh my gosh, bro. What the hell? Okay, hold on. Let's see. So actually, you know what? I'm just gonna make sure that I do this instead. Okay, I have a much better idea. A way better idea. Do like this. Beginning of line. I'm gonna yank everything. And we're just gonna quit. You're gonna let me quit? Thank you. Now, if I list it, it should not be appearing. Run CPP, it should not be here. Perfect, okay. So what I'm gonna do is I'm gonna actually just CD somewhere else. Like let's say users, Ryan, desktop. That's fine. Now I'm gonna open NeoVim, create a new file. And I'm gonna basically, can I do this? Perfect. All right, sick. So with that being said, now I'm gonna write quit. Oh, right, I gotta give it a name. NeoVim run cpp.ch. Do this. Okay, great. Now I'm gonna write quit. Perfect. Okay. Now what do I do is I give it its permissions. So I gotta do cmod plus h run cpp.ch. Perfect. Okay. Now what I'm gonna do is I'm gonna move run cpp.ch to I guess this. Wait, hold on. Okay, so I'm going to move it. I'm going to move run cpp.ch. I'm going to move it back once, move it back again, and going to user, going to local, going to bin, move it there. Oh my gosh. Okay. Oh, that's why. Wait. Did I do something? You gotta be kidding me. Wait. Bro, I'm actually about to crash out. Let's see, go to my desktop. Oh. Where am I? Yo, bro, I'm actually about to crash out. Okay, hold on. What even is this directory? Okay, now how do I go? Is this... About it, bro. Oh my gosh, I'm actually about to crash out. And I have a dev folder here. What is this? Yo, what is going on? Hold on. Oh, users. Okay. Ryan, desktop. Now, I have something here, which is run cpp.ch. I want to move. Wait. Oh, shoot. Right now, my script is on my desktop. How do I move it to, let's say, I don't know, to 3 directories behind, then you enter user / local / bin. Bro. Okay, so first I'll go on my desktop. I'm already here. No, user / right, so just okay. Now I'm gonna move it back, move it back, move it back. It's a read-only file system. Yo. Holy shit. Yo, I'm about to actually crash out. Okay, let's try that actually. Let's try doing this. Sudo move from here / run cpp.ch, move it to /. Is there a message in chat? I actually can't see anything. Shoot. Wait. What's up, Justin? I'm just setting up a script to compile my C++ files, but bro, oh man, I'm making it too complicated. Wait, hold on. So let me just read what I have to do here. Okay. Now what I have to do is I have to move it to there. Okay, I think I need to put my password. Okay. Yo, I'm actually so pissed right now. Yo, bro. Okay. Is there any way to create global scripts normally? How do people usually do that? Like Let's see. Bro, ChatGPT, chill, bro. Bro, that is so much better. What? I don't understand. Wait. I'm gonna move it to here, to local / bin. Did that work? Wait, hold on. What? Oh, okay, I see. Okay. To bin. Okay, so that works. Now what we're going to do is we're going to go back into this, and then to dev/practice cs/dev/practice and learning/cpp list. Okay. Oops. Bro, I'm actually tripping so bad right now. Okay. So this is hello world, and now I'm gonna open my terminal, and let's see. /run cpp .sh, and what? Okay, it's okay. Forget about it. I'm not okay. All good. I'm gonna stop with the crash out before I actually crash out. So I'm just gonna forget about the script. I'm gonna go back into my thing over here. I'm gonna remove recursively bin. Oops, recursively bin. And there you go, it's clear. So now I'm gonna go back to, let's say, users/Ryan. No? Okay. Users/Ryan desktop. Okay. CD into, let's say, I'll go into CS/this. Okay. So let's go back to what I was doing. That was such a useless like 10 minutes, bro. Oh my gosh. What the hell, bro? That was the worst 10 minutes of my life. Like what actually just happened? Oh my gosh. Unbelievable, bro. It's crazy. So anyway, yeah, so the size of function, I guess it's like if I want to do client ++ this, and then I actually run ./hello world, it gives me 4 and 1. Yeah, because on my architecture, I guess an integer is 4. It takes 4 bytes. Prints how many bytes, right? Size of, it prints the number of bytes. I'm gonna try to remember that. And how do I remember that? It's because from the Coding Jesus, who was a YouTuber, he always asks this question to people: size of that function, does it show bytes or bits? It's bytes. Print how many bytes of memory an int value takes. I'll try to remember that. Okay. Anyway. So unspecified behavior is almost identical to implementation defined behavior in that the behavior is left up to the implementation to define, but the implementation is not required to document the behavior. Okay. So we generally want to avoid implementation defined and unspecific behavior, as it means our program may not work as expected if compiled on a different compiler, or even on the same compiler if we change product settings that affect how implementation behaves. Okay. So avoid implementation defined and unspecified behavior whenever possible. Cool. So an uninitialized variable, it's a variable that has been defined but has not been given a value yet. And you should avoid using them because if you don't assign, basically if they are uninitialized, then when they are basically defined, they are there is a memory that is allocated for them in a CPU register or in RAM, and whatever garbage value there is in that memory that it's been allocated to. That's what its value is going to be if we don't initialize it or assign it rather a value. Anyway, that should be the solution. Yeah. And it results in undefined behavior. What is undefined behavior, and what can happen if you do something that exhibits undefined behavior, unspecific behavior? It's a result of executing code whose behavior is not well defined by the language. And this result can be almost anything, including something that behaves correctly as well, which is how bugs can hide from us for a very long time. Next lesson, finally, keywords and naming identifiers. So C++, it reserves a set of 92 words as of C++ 23 for its own use, and these words are called keywords or reserved words, and each of these keywords have a special meaning within the C++ language. So here's a list of all the C++ keywords. Actually, I'm gonna go drink some water, so I'll be back. Yeah. Oh, my charge is going way fast. Shit. I need to plug in my laptop. Oops. All right, perfect. Okay, let's continue. All right, so C++ reserves a set of 92 words. These are called keywords. Here they are. Okay. Interesting. Okay. Yeah, that makes sense. Okay. Now, as a reminder, the name of a variable or function type or other kind of item, it's called an identifier, and C++ gives you a lot of flexibility to name identifiers as you wish. However, they cannot be a keyword. It can only be composed of letters, numbers, and the underscore character. Okay. Okay. Makes sense. It has to begin with a letter. Okay. Or an underscore, and it's case sensitive. Okay. Okay. Interesting. Okay. Okay. I see. I'm so cooked. Anyway. These are just best practices, I guess. Okay. So these are just best practices. Cool. Whitespace and basic formatting. Whitespace is a term that refers to characters that are used for formatting purposes. In C++, this refers primarily to spaces, tabs, and new lines. Okay. Whitespace in C++ is generally used for three things: separating certain language elements inside text and for formatting code. Okay. Yeah, so those have to be whitespaced, right? Okay. A function's return type and name must be whitespaced. Yeah. But that's okay. Yeah. Okay. 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 So those have to be separated on separate lines. Okay. Uh-huh. Okay. Okay. So it's just formatting. Okay. Okay. Yeah, Vim also uses this. I don't see the difference. Oh, I see. So you can put comments on the same kind of spacing by aligning the comments. Okay, cool. Nice. Harder to read. Okay. So now finally we're going to talk about literals and operators. By the way, I think this is almost done with this first section. Yeah, okay. Nice, we're almost done with the C++ basics, and then we can start looking at functions and files. This should be pretty good. And then debugging, and then fundamental data types, and whatnot, and have a lot of fun with all that stuff. But I have to do my basics, of course. Okay. Let's see. So introduction to literals and operators. Okay. So what are hello world and 5? Well, they are literals. A literal, also known as a literal constant, it's a fixed value that has been inserted directly into the source code, right? Literals and variables both have a value and a type, unlike a variable whose value can be set and can be changed through initialization and assignment respectively. The value of a literal, it's fixed and it cannot be changed. And the literal 5 always has value 5, and this is why literals are called constants. Now, to further highlight the difference between literals and variables, let's examine this short program. Okay. So we're printing the value of the literal here. I'm printing the value of a variable that contains that, or at least that is associated with this, that has the value 5 essentially. So on line 5, we are printing the value 5 to the console. Okay, cool. On line 7, we're creating a variable named x, initializing with 5, and then the computer will generate code that copies the literal value 5 into whatever memory location is given to x. Okay. Wait. Okay. On line 8, when we print it, it will generate code that causes that to print the value at the memory location of x. Okay, so thus both output statements do the same thing, but in the case of the literal, the value 5 can be printed directly, and in the case of the variable, the value 5 must be fetched from the memory the variable represents. And this also explains why a literal is a constant, while a variable can be changed. So a literal's value is placed directly in the executable, and the executable itself can't be changed after it's created. A variable's value is placed in memory, and the value of memory can be changed while the executable is running, of course. Cool. In mathematics and operation, okay, so these are operators, operands over here. Oh, they produce a new value, blah, blah, blah. Okay, great. Okay. Okay. Now the number of operands that an operator takes as an input, it's called the operator's arity. Yes. Okay. Yeah, an unary operator acts on one operand, so it's kind of like a function, actually, like a one-dimensional function. Right? Okay. Okay, cool. Binary, tertiary, ternary, nullary. The throw operator, okay. Some operators have more than one meaning depending on how they're used. For example, operator minus has two contexts. It can be used in a unary form to invert a number sign, or it can be used in binary form to do a subtraction, right? And operators can be changed. I think the reason as to why we're even talking about operators is because maybe we can do something interesting in C++, like how in Python we can specify for a given class what a given operation like means, like addition and multiplication. We might be able to do the same thing in C++. Maybe that's why we're talking about it. I don't know. I guess we're gonna find out. Let's see. It follows PEMDAS. Okay. Yeah. Okay, this is interesting. So most operators in C++, they just use their operands to calculate a return value. Okay. Okay. Now some operators have additional behaviors. An operator or function that has some observable effect beyond producing a return value is said to have a side effect. For example, x is equal to 5, it has the side effect of assigning value 5 to variable x. And the change to value of x, it's observable by printing the value of x. Even after the operator. Right, so the changed value of x is observable even after the operator has finished executing. Okay. Let me see. This has a side effect of printing 5 to the console. We can observe the fact that 5 has been printed to the console even after this has finished executing. Okay. Right. Okay. What return value does this operator even have? Interesting. Bro, I wish I could read the chat like normally, but like for some reason it just like the chat is like kind of bugging. Like I just can't see very well. Wish. I'll do this instead. Qu'est-ce qui se passe, bro? En forme. En effet. Right. What's up, Amateur Chess? And Justin. By the way, guys, I guess I'll specify if Amateur Chess you're new, or like Pierre. I mean, I know you're watching probably right now, but like the reason as to why I do these streams is because I want to just document for myself my journey as I learn how to code. But sometimes if I get viewers, that's really awesome and whatnot, and people can join the journey. But if not, like it is what it is. Like I just want to be able to see in a year on my YouTube channel that like, oh nice, I have all these videos of me learning how to code. So yeah, that's the main part. Yeah. But I'm glad whoever 3 people are watching right now are watching. Thank you. But I'm just reading and learning. That's it. There's nothing exciting here. Yeah. Anyway. Okay. Okay. Anyway, so operators in C++, I think that's about, okay, right. So what return value would you expect x is equal to 5 to have? I have no idea. What could it possibly have as a return value? Well, both operator is equal to and operator like this puts to, when used to output values to the console, they return their left operand. Oh, okay. I did not know that. That's cool. So x is equal to 5, it returns 5. It returns that. Okay, cool. And what else? Wait. Oh shoot, what did I just do? Wait. I'm messing up my what do you call it? I'm accidentally messing up my OBS. Oh shoot. What is going on, bro? Wish. Yo, what? How do I minimize this? Wait, hold on a second. Like my screen is just fully like whatchamacallit, the live chat. I can't even close it. Wait. Yo bro, how do I close this? The hell? I can't even see anything on my screen anymore, like on my laptop, not that screen, but this one. Yo. Wait, hold on. Oh, okay, I got it. Wait. Yo, what? Oh, I'm good. Yo, I'm gonna actually crash, huh? Oh my days, bro. This always happens to me. Yo, how do I minimize this before I lose my mind? Yo, I'm actually about to lose my mind. Oh my days, fam. Oh, okay. Did I get it? Yes, I think so. Oh my gosh, I didn't. Oh my gosh, bro. Oh my gosh. Wait, hold on. I need to minimize my thing so I can see OBS. Bro. Okay, this is minimized. Yo. Okay, whatever. I don't even care anymore. It's all good. Okay. So, let's see. Is that my revenue? Wait, let's see. Bro, now my revenue is open. Quick notes. Yo, I have no idea what's going on with my computer right now. And also, this keeps opening. Okay, am I getting hacked or some shit? Yo, this is not good. Yo, am I actually getting hacked or some shit? Like, I don't understand. Like, I was just kidding when I said that at first, but like, now I'm thinking that like this is actually kind of suspicious. Like, my notes keeps opening and the hell? Yo, what is going on? Okay, well, too bad for me, I guess. I won't be able to minimize this, but what do you want me to do? There's nothing I can do. Yeah. Yep. Okay, what is going on? Holy shit. Okay. I think I'm gonna low-key have to just like quit the stream at this point. Yeah. Low-key. Low-key, high-key. It's kind of sad, but I low-key, I think I actually have to quit the stream because it's just not working. Okay, whatever. I actually don't care. It's okay. But anyway, I feel like I should record a video though. Otherwise, like separate from what do you call it? Like these coding videos. I wanted to record a video talking about something related to CS and just post it. I think I'm gonna actually do that right now. That seems like a good idea. Anyway, I'm gonna close the stream, I guess, because like my OBS just started bugging and now I can't do anything anymore. Like my screen is just like it's dead. So, goodbye.